Ares is America's rocket. It is the new rocket. It is the rocket that is going to replace the shuttle.
This is the next generation's rocket.
With the Ares program, we're not only replacing the space shuttle and keeping manned space flight alive, we're also planning for the future.
We're building the capability to establish a lunar base.
Experiment with living in outer space.
Return to the moon and then ultimately on to Mars.
What I think is most exciting is that it's all new. You know, the United States has not built a new space vehicle in almost 30 years.
We've learned a lot from the Apollo program. We learned a lot from the Space Shuttle program. Let's take the things we learned and blend those together to have a successful, robust system.
Ares 5 will be the largest launch vehicle that the world has ever seen.
If you think of the Ares 1 as the SUV of the space program, the vehicle that gets the astronauts to space, the Ares 5 would be the semi-truck. It's the cargo vehicle that can take a lot more stuff than the Ares 1.
That will allow us to throw about 65 tons to the moon. We could fit about 7 full-size school buses. That's about 3 times more volume than any launch vehicles that fly today.
It takes all kinds of people with all different backgrounds to put this vehicle together to get man in space.
My job is a system engineer.
I'm an integration project engineer. You have a lot of individual components that when they work by themselves, that's great, but they need to work all together for a successful vehicle.
The most challenging aspect of my job is basically understanding and knowing how all the parts must come together in order for the launch vehicle to fly.
I am a manager over the energetic materials and processes.
I'm the advanced planning manager in the Ares Projects Office.
My official title is Ares 1 First Stage Systems Engineering and Integration Engineering Lead, which is a mouthful, I understand. What I really do is I lead the group of engineers that are helping to make sure that the first stage is being designed to the correct requirements.
I'm the office chief of procurement.
I'm a contract specialist.
We buy engines.
Here's a model of the J2X engine.
I'm a graphic artist here at NASA, working on Ares.
My particular expertise is in the welding of metallic materials.
I'm a writer on the Ares project. We want to document the history of the project as it unfolds. There's a huge amount of interest in Ares. We're headquartered at Marshall, but the project's nationwide.
I'm the subsystem manager for manufacturing and assembly for the upper stage rocket.
What I work on is actually the reaction control system. That's all the smaller engines that keep that rocket straight and pointing in the right direction.
I've been a test engineer at the Marshall Space Flight Center for about 20 years now. This is the top of the dynamic test stand. And this is where we'll be bringing the Ares 1 rocket for dynamic testing.
We have to constantly test.
Test it and look at the data.
1, fire. 3, fire.
Now once we get that data, we have to go back and analyze it.
Math and science is essential in this business.
We got to do the electric connections, and we got to keep it away from the engine.
When we move to inside 90 degrees.
Look at these rates right here. We might need to make sure that those rates are adequate for this year.
Okay.
Rocket propellant is based on redox chemistry, which is a fundamental chemistry process that you learn first off in your chemistry classes.
How much thrust does it take to lift 2 million pounds off the Earth?
Engineers are all about solving problems. That's really our job title.
How did we solve it?
We used the laser tracker to figure out the coordinates 22.5 degrees. We did a re-verification last night. It looks like we're good to go.
You know, with Photoshop, I can enhance these areas to let the upper stage pop out.
That rocket's burning at around 5,600 degrees Fahrenheit. Steel not only melts at that temperature, it boils. We need to protect that metal hardware.
Building a launch vehicle requires teamwork.
We have teams literally spread across the country.
We'll have the very bottom of the vehicle coming in from Kennedy Space Center, the first stage segments coming in from Utah by rail car.
We're working with engineers at the Johnson Space Center in Texas, Langley Research Center in Virginia, Glenn Research Center in Ohio.
And Boeing is our production partner on the upper stage.
We have ATK launch systems located out in Utah.
We have an incredible team of people that are going to make this a reality.
I feel like I'm a part of something bigger.
We've got a great chance to be part of history.
Just to be part of it is just more of a privilege to me than anything else.